Hello everyone, hope you're all doing fine. So today's topic is vaccine. Vaccine, as we know, it is a biological preparation that improves immunity to a particular disease. Or we can say vaccination is the administration of antigenic material to stimulate one's own individual or one's own immune system to develop adaptive immunity to pathogen. So, if you don't know what is adaptive immunity or anything about immunity, I just want to give you a little bit of intro about immunity. The word immunity itself comes from the word immunis, which means exempt state of protection from infectious disease. Our immune system is our body's defense system. It works like recognition and response, and the immunity have two classification: innate immunity and adaptive immunity, where innate immunity is less specific, first line of defense, and adaptive immunity is more specific and second line of defense. And the innate immunity works with four type of barriers: anatomic barrier, physiological, phagocytic, and inflammatory barrier. So by vaccination, we are increasing our adaptive immunity. So as I said before, vaccination is the administration of antigenic material to stimulate an individual's immune system to develop adaptive immunity to a pathogen. So here you can see some pictures. The first picture demonstrates the plague in Athens, which happened in 430 BC. And this is the picture of Lady Mary. She performed variolation process in her children to resist some infectious diseases. And this picture is when they found the vaccination for polio. This is important milestone in the process, or important milestones in the vaccination process. The vaccination is the real result, or due to this vaccination, we have worldwide eradicated the smallpox and elimination of the disease such as polio, measles, and tetanus. And the vaccines should have these basic characteristics like it must be affordable, it must be heat stable, and only it must be used to single dose and effective to a number of disease, and it must be administered to mucosal route and suitable for administration in early in life. The immunization which given by the vaccine can be active or passive. So the vaccination is injectable vaccine that immunizes individual from various diseases, and immunization is the whole process of vaccine, and vaccination is collectively known as immunization. And how the vaccines work. A weakened version of the disease or virus is injected into the body, and in response the body creates antibodies that fight the weakened version of the disease. And later, if the body is exposed to the disease, the antibodies remember and are able to fight it effectively. So antibodies remember it. So what happens is it's the part of adaptive immunity. We have already mentioned about the adaptive immunity. It is when we classify the immunity into two: innate immunity and adaptive immunity will be there. And adaptive immunity is more specific, second line of defense, and it have four main characteristics like it is antigen specific, it is diverse, it have self or non-self recognition, and it have immunological memory. So that's what mentioned here. So the acquired immunity or adaptive immunity can be active immunity or passive immunity. Active immunity is produced by the host itself, host immune system itself, producing an immune response. And passive immunity, no participation of host immune system. And in active immunity, it is induced by infection or by contact with immunogen, and it is durable and effective. Time required for the generation of immunity, so we need time. Our body, because our body is creating that immune response or that immunity. So it needs some time. And negative phase may occur and not applicable in immunodeficient host. And passive immunity is not by our host immune system. It is conferred by the introduction of host antibodies, transient and less effective, and immunity affected immediately and non-immunological memory, no negative phase, and applicable in immunodeficient host. Next, there is different kinds of vaccine. Killed vaccines, live vaccines, edible vaccine, toxoid, subunit, recombinant vaccine, peptide vaccine, DNA vaccine, and conjugate vaccine. And we are going to deal with it one by one. This first vaccine is, so the first vaccine is killed vaccine. That vaccine is made by the antigenic material which is harming us. That antigenic material is, or microorganisms, is killed to prepare this vaccine. So the organisms are killed by in different methods like heat, formalin, phenol, alcohol, and ultraviolet light, or photodynamic inactivation. And it can be preserved in phenol, alcohol, or methylite. So less immunogenic and immunity lasts for a short period. Booster doses are required. Its example is example for the killed bacterial vaccines is TAPE for enteric fever and cholera vaccine, and purchases for whooping cough. And killed viral vaccine, example for that is Salk vaccine for poliomyelitis and rabies vaccine, hepatitis A vaccine and hepatitis B vaccine, and influenza vaccine. And each and every vaccine, each and every type of vaccine have its own advantages and disadvantages. So first we are going to say about the advantages. It is safe to use and can be given to immunodeficient and pregnant individuals, and it is cheaper than live attenuated vaccines, and storage is not as critical as live vaccine, because live vaccine is a little bit, when you store it, we feel some difficulty to store it because it may reverse its activity. When it is live attenuated vaccine, live vaccine, the bacteria or the antigen is alive. So disadvantages, since a microorganism cannot multiply, a large number are required to stimulate immunity. Periodic boosters must be given to maintain immunity, and only humoral immunity can be induced. Humoral immunity, which is through the body fluids. And most killed vaccines have to be injected. So killed vaccines want to be injected, no other options. And then moving on to the live vaccines. As the name indicates, the antigen or microorganism will be alive. It can be attenuated by aging of culture, but it is attenuated. That is, attenuation means it is created by reducing the virulence of a pathogen, but still keeping it viable. Okay? So it takes an infectious agents and, making it less harmless. Not less harmless, less harmful. Okay? So different kinds of vaccine is available, live attenuated, like viral vaccines, example for the measles, mumps, rubella, influenza, rotavirus, yellow fever, and the bacterial vaccines like BCG, and the vaccines for oral typhoid, etc. Example for this live attenuated vaccines. So this attenuation of the microorganisms can be done by different methods. The virus can be attenuated via passage of virus through the foreign host, such as tissue culture, embryonated eggs, and live animals. Okay, there is different ways. So this immunity will last for several years. Booster dose does not require, like in killed vaccines, and storage condition of less than 0 degree is necessary. So examples is given here. And advantages. Infectious microbes can stimulate generation of memory, cellular as well as humoral immune responses. So in previous one, the humoral immune responses is only done, and here there is cellular as well as humoral immune responses. And then since they can multiply in the host, fewer quantities must be injected to induce protection. Oral preparation are less expensive than giving injections, and they can lead to elimination of wild type virus from the community. And disadvantages is may very rarely revert to its virulent form and cause disease. Live vaccines cannot be given safely to immunosuppressed individuals since they are live and because they are actively depends on their viability. Proper storage is critical. And the next is toxoid vaccine. Toxoid vaccines are made from inactivated toxoid compound that cause illness rather than the microorganism. And an example for this is given here diagrammatically. This is tetanus bacteria. Okay, that tetanus bacteria emit a type of toxin, that is tetanus toxin. Okay, that is harmful. Okay, that toxin which is it secretes. So it is modified to tetanus toxoid and used as a vaccine. That is toxoid vaccine. Example is tetanus and diphtheria. Toxoid vaccines are known for their efficacy. And the next type of vaccine is subunit vaccine. So the subunit vaccine is, subunit vaccine, it contains purified antigens instead of whole organism, consists of only those antigens that elicit protective immunity, composed of toxoid, subcellular fragments or surface antigens. Effectiveness can be increased by giving them in adjuvants. Example, vaccine against hepatitis B virus that is composed of only the surface protein of the virus. So it's not using the whole organism. It's only using some subunit, some part of that organism. Okay, this human papilloma virus and the human papilloma surface subunits, surface proteins is taken here, as you can see, because it is only a subunit. It's not the whole organism used here. So advantage is they can safely be given to immunosuppressed people and they are less likely to induce side effects. So it's a good advantage. And when we move on to the disadvantage of the subunit vaccines, antigen may not retain their native conformation, so that antibodies produced against the subunit may not recognize the same protein on the pathogen surface. Isolated protein does not stimulate the immune system as well as a whole organism vaccine. Next, the peptide vaccine consists of those peptides from the microbial antigen that stimulates protective immunity. Peptide immunogenicity can be increased by giving the ISCOMs, and the example is SPF66 anti-malarial vaccines. So peptide vaccine is where we use the peptide portion of the microorganism or disease-causing agent. And the conjugate vaccine is developed against capsulated bacteria. The polysaccharide antigens are T independent. They generate short-lived immunity. Immunity to these organisms requires opsonizing antibodies. Infants cannot mount good T independent responses to polysaccharide antigens. Hemoinfluenza HIV polysaccharide is complex with diphtheria toxoid. It's an example for the conjugate vaccine. It is really developed against the capsulated bacteria. And the recombinant vaccine, genes for the desired antigens. We are using the rDNA technology for producing this recombinant vaccine. So genes for desired antigens of the microbe are inserted into the vector. As you can see, this is hepatitis B virus. It will have the genetic material DNA or RNA. And we are taking a portion which HB antigen producing gene. That's the only portion we need. And we are taking it, and from a bacteria, in a bacteria there will be a bacterial DNA and plasmid DNA. So we are taking that plasmid DNA and it is cut with the restriction enzymes. And then this HB antigen producing gene is inserted into with the help of some ligase or something else. And not something else, we are usually use this ligase to stick it up. And then this introduction of this recombinant DNA into yeast cell. And this recombinant yeast cells is put up into the fermentation tank and produce lots and lots of cells. And HB vaccine is produced by extraction and purification. So this is an example for the recombinant vaccine by using the DNA technology. And the DNA vaccine composed of bacterial plasmid. Expression plasmid used in DNA-based vaccination normally contain two rules: antigen expression units and production units. So the construction of this DNA vaccine is gene for the inner immunogen. It is inserted into gene into a expression plasmid and transform bacterial cells, grow bacteria, purify plasmid DNA and immunize with immunogen expression plasmid. So the administration of this DNA vaccine is, I think, a little bit of complicated, because intradermal injection of DNA coated gold particles with a gene gun have been used, and there has also be positive demonstration of pro-injection or co-delivery with various drugs. So you can see the delivery methods, advantage and disadvantage. And then the last one, I think, edible vaccine. Edible vaccine is also by, I think, rDNA technology. So obtaining edible vaccine, selected gene of interest is administered to the plant. Transgenic plant is then induced to manufacture the encoded proteins. So edible vaccines are targeted to provide mucosal as well as systemic immunity. First report of edible vaccine was published under International Patent Cooperation Treaty in 1919s. So how to make an edible vaccines is shown here. So the ideal properties of edible vaccine: it should be effective, it should be affordable. And the edible vaccine, when we introduce an edible vaccine, the process of delivery or vaccination is really simple, right? We just want to eat it. So it is that simple. And it must not contaminate the environment. It must it must ensure the long lasting humoral and cellular immunity. It doesn't want to have any side effects. It must be non-toxic or non-pathogenic. So the application of this edible vaccine is preventing infectious diseases, preventing infectious diseases, autoimmune disease, and cancer therapy. An administration of edible vaccine to mothers might be successfully immunizing fetus in utero by transplacental transfer antibodies. And the edible vaccine is also used to following diseases like malaria, measles, hepatitis B, cholera, diabetes. So this is about the vaccine. This is a short class on vaccines. Hope you like it. Thank you.